the stargazers. Meanwhile, on the flat plain of the Middle East, civilization was taking another course, and so was the practical geometry, with the accomplishments of the stargazers, who divided the circle and became the world's first systematic astronomers. We can imagine how the night sky must have looked to the earliest stargazers in the valley of the Tigris and Euphrates rivers. Those people of old watched the familiar star patterns move across the heavens. They watched the great drama of the procession of the constellations as if it were a gigantic circus parade. In that starry sky, the ancients picked out figures of human beings and animals and identified them with heroes and gods. They passed on their ideas to others, and they still call the constellations by names that trace back to those times. And we still use direction-finding tools that derive from instruments they made while stargazing thousands of years ago. Early people of the plain, the Sumerians and Chaldeans and Babylonians, needed a guide for their travels and wanderings and wars across that broad, flat region. They found it in the stars. This was a necessity the ancient Egyptians never experienced. Civilizations of the River Nile and the Tigris and Euphrates had progressed in the same direction in measuring off land and building irrigation canals, but varying geographical conditions impelled them to develop later along different paths. The Great Nile River was itself a well-defined highway between the settlements of Upper and Lower Egypt. Its narrow valley was protected by mountains and deserts on both sides. For centuries, this isolated valley was free from foreign invasion, and people were able to pursue the arts of peace. Wall paintings still exist after more than 5,000 years that show the Egyptians at work and play, living industrious or leisurely lives in efficient, luxurious, and artistic surroundings. But the valley of the Tigris and Euphrates, called Mesopotamia, the land between the two rivers, extended over broad, flat plains dotted with little cities. Nomadic tribes roamed over the plains and made war on one another and on the city dwellers. And the many city kingdoms made war on each other too. The wall pictures from this ancient land show warriors, chariots, weapons of war, and war machines. In addition to this endless warfare, the people of the plain were famous traders. They had no wood or metals, and they needed both for their cities, so caravans of donkeys and camels and flotillas of sailing boats set out constantly to exchange goods with neighboring and faraway lands. All this created a problem. Mesopotamia was so extensive and so bare of natural landmarks that people had to find a way to lay out directions for their wars and their travels across and beyond the valley. The solution was finally found by their stargazers, ancient astrologers held in great esteem, as were the rope stretchers along the Nile. In the Nile Valley, people built tombs for their pharaohs. In the valley of Tigris and Euphrates, people built temples to their sky gods atop lofty ziggurats, broad tiered towers for their stargazers. From these high platforms, the astrologers were better able to watch the whole sky and study and interpret the star movements that they believed directed human affairs. These temples supervised the life of the community. In return, the people presented a portion of their livestock and crop to their stargazing priests, part to be used in sacrifice to their gods, and part as taxes to be kept in the temple sanctuary for the support of the government. In time, the temples became observatories, and the stargazers became astronomers and solved problems of measuring the travels of distant stars. Already these stargazers had noted the messages of time and direction in the shadows. They had observed the changes in the position of the rising and setting sun through the year. They had used the phases of the moon, its periodic growth and waning, to regulate their early calendar. They had watched the steady movement of star groups across the sky and travels of the wandering planets in relation to a fixed star. But they needed an instrument to measure more exactly this brilliant parade across the star-studded heavens. The people needed to measure needed a measure of direction for travel on the earth. The priests needed a measure for the travels of the stars in the sky. These needs led them to find a very important secret from the circle. We do not know just when or where an unknown stargazer or stargazers made the discovery. The idea of pointing the sides of an angle at two stars must have been very ancient. Holding up a string to measure the distance between them was useless, since the length changed as you brought it closer to your eye. But how could you measure an angle? The answer lay in the division of the circle into 6 parts. This was the earliest and easiest circular partition, and Egyptians as well as Mesopotamians used it for sky measurement. Perhaps we can imagine how it was discovered. The power of the stars. The Egyptians, we know, gave credit for the abundant crops to the rope-stretching surveyors who constructed and maintained the life-giving irrigation ditches. For their part, the people of Mesopotamia believed that if messages from the sky regulated the seasons, they must also regulate people's activities. They thought that movements of heavenly bodies controlled and forecast important human events, so they gave credit to stargazing priests who studied these movements. Dividing the circle. Possibly an old stargazer looked back on childhood games, recalled tracing a perfect circle on the ground with a string, and used string and stylus to draw a circle on their clay tablet. Now, how to divide it? Perhaps the stargazer was just toying with a string, or thought of a field of 6-petaled flowers, or remembered something children did in the game. After their feet had scuffed out a circle on the ground, sometimes one child stood on the scuff marks and held the string while other children went round in a circle in a series of 6 arcs. Using the same length of string they used to draw the circle. When the stargazer swung these arcs clear through the circle, the flower pattern with its 6 petals appeared. Their discovery was simply that these arcs would cut the circumference into exactly 6 equal parts. However, by chance or by intuition, the stargazer hit upon the secret of dividing the circle into 6 equal parts. After that, it was an easy matter for other stargazers to go on dividing their arc in half and then in half again. But how many times should they redivide it? The ancient Mesopotamians counted by sixes and tens. Their earliest stargazers thought the year had 360 days. So, what could be more reasonable than to continue dividing this circle with its 6 convenient arcs into smaller and smaller parts until there were 360 tiny divisions in all. With these tiny divisions, the stargazers had a new convenient unit of measure. The arcs on the circumference of the circle would measure the corresponding angles at its center. As soon as this discovery was made, measuring the path of a star or a planet was easy. Ancient astronomers attached the movable pointer to the center of the semicircle. With this device, they could follow the planets and measure off their distant travels in units of angular measure on the semicircle. Using the same device, land directions were easy to indicate too. They could mark off directions on the Earth from the east. That is, from the position of the rising sun on the day and when it rose midway between the furthest points where it had risen during the year. And these unknown stargazers left us a monument in the division of a circle. From that time on, tables of measurement of the star movements were kept in the temples, recording eclipses. As far back as 4,000 years ago, these ancient astronomers, with their pointers and semicircles and quarter circles, quadrants, and 6 circles, sextants, observed and recorded ellipses of the moon. But at that remote time, such observations were only occasional and unsystematic. Gradually, it became the custom to make more frequent observations until in 447 BC, the series became continuous and a record was carefully kept. What had started as astrology became a science when people collected the first long series of astronomical observation. It lasted more than 300 years, the longest uninterrupted table ever kept to this day. Through these records, the constant pattern could be seen in the periodic movements of the sun, moon, and planets, a pattern that enabled people to foretell the time of a future eclipse and the future position of these celestial bodies, the wheel and the arc. Apart from their astronomy, the Mesopotamians left us with great monuments to their division of the circle, the arch, and the wheel. They were probably the earliest people to use the wheel, and when they changed from their older solid wheels to wheels with spokes, the divided circle, they created light chariots for their wars.